This is problem number 10 for section 3.1. In this problem it says, what is the rate of change of the area of a circle a equals pi r squared with respect to the radius when the radius is r equal 9? So they're asking us for the rate of change of the area of the circle. Well, to find rate of change, we need to find the slope. And they give us this function, so we need to find the slope expression for this function. And to find the slope expression, we're going to get the limit as h approaches 0 for f of x plus h minus f of x all over h. And we're going to do that for this function here. So we're going to say that that is equal to the limit as h approaches 0. We have a equals pi r squared, so we're going to essentially ignore the a part of this and just focus strictly on the pi r squared part. So we don't need to worry about this a part here. So we're going to say that that's going to be pi x plus h squared minus the original function, which is it would be just pi x squared all over h. X plus h squared, that's x plus h times x plus h, which is x times x, which is x squared, x times h, xh, h times x, also xh, so that's two of them, plus h squared. We can now take this and plug it in for the x plus h squared there, so it's a limit as h approaches 0 for pi x squared plus 2xh plus h squared minus pi x squared all over h. We're going to distribute the pi, so we end up with limit as h approaches 0 pi x squared plus, we're going to get pi times 2, so it's really 2 pi xh plus pi h squared minus pi x squared all over h. The pi x squared and the negative pi x squared cancel, and we're left with limit as h approaches 0 of 2 pi xh plus pi h squared all over h. Let's factor in h out of the top. We got limit as h approaches 0. This is h. What's left is 2 pi x plus pi h all over h. The h's cancel, and you're left with limit as h approaches 0 of 2 pi x plus pi h. When you plug in 0 for h, cancels that term, we're left with 2 pi h. This is the expression for the rate of change, or the slope, for a circle. So if we want to know the rate of change of the area with radius 9, we take this expression and we plug 9 in for h. Or not, this should say 2 pi x. I screwed that up. That should say 2 pi x because it says 2 pi x right there. So this should be 2 pi times the x value, which, remember, the x value is just the r value in the original problem. So 2 pi times 9, which is going to be 18 pi. So the rate of change of the area of the circle with respect to the radius, so as the radius changes, the rate of change of the area increases with a radius of 9 to 18 pi.